I'm going to cover 3 techniques for solving limits analytically. The first thing I always want to do is direct substitution, see if it works. So if I plug 1 in, I get 1 minus 1 plus 2 on top, I get 1 minus 1 on the bottom, 2 over 0. So this does not exist. It's undefined. All right, well, we're not going to see that very often, but always try that first just to make sure. All right, let's try it again to put this one approaching 3. Now, if you plug in 3, you're going to get 0 to 0, which is indeterminate. Okay, but here's a technique now. This is the factoring and cancellation. So factor the top, then clearly you can cancel. Now, the function x squared minus 5x plus 6 over x minus 3 is different than the x minus 2 function. They both look like this straight line, y equals x minus 2. However, the first one has a hole right here. The second one has no hole. But the point is with the limit is we're not actually getting to the hole, we're just getting infinitesimally close, which is why this limit is the same as this limit even if the functions are different at that one point. So you plug in 3 now, and you get 1. So the limit does exist. Another example, same technique. Alright, this, if you plug in 3, is 0 over 0. Now, this is a difference of 2 cubes, which you may have forgotten how to factor. Here's a formula for how to factor it. You see the signs switch over here. So what we can do is factor the top, x minus 3, x squared plus 3x plus 9, cancel some x minus 3, then you can evaluate the limit, and you get 27. Another example over here, if you plug in negative 4, you'd have 0 over 0, which is, of course, indeterminate. So let's try to factor. Now, figuring that the bottom is probably going to have an x plus 4 when you factor it, you could do synthetic division, put a negative 4 into 1x cubed, 0x squared, 0x plus 64, and you realize you get this if you do out the factoring. So it's one way to think about it. And then you can cancel these and plug in your negative 4 and you evaluate your limit. So that's cancellation. Here's rationalization. Rationalization is, if we plugged in 4, we would have 0 over 0, it's indeterminate. So what we do is we rationalize. In this case, we have to rationalize the numerator, as opposed to say the denominator, multiplied by the conjugate. So red x plus 5 plus 3. Now on the top, it's red x plus 5 squared, which is x plus 5, minus 3 squared, which is 9. On the bottom, do not multiply these out. That will not help you. Okay, don't distribute any of this. And the reason is because then the top becomes x minus 4, and then you can cancel these, so you don't want to multiply that, you just have to factor it in anyway. You cancel these, then you can evaluate your limit by plugging in 4, and you get 1/6. Okay, again, this is a rationalization, so this would be 0 to 0 if you plug in negative 3. So multiply the top and bottom by 5 plus red x plus 28. The top, don't do anything with. Leave it like that, because on the bottom, you're going to have 5 squared minus red x plus 28 squared, so 25 minus x plus 28. This part on the bottom becomes negative x minus 3. So what we do is leave everything the same up here, but factor out a negative on the bottom. So we have negative times x plus 3, so then those cancel, and then you can evaluate with a negative 3, and you end up with negative 10. Another type is nested fractions. Okay? Nested fractions. And so if you plugged in negative 1, you'd have 2/3 minus 2/3 on top, negative 1 plus 1 on the bottom, so 0 to 0, indeterminate. So what we do is we get a common denominator within our numerator. So I multiplied this one top and bottom 3 over 3, this one top and bottom x plus 4, and so then I have 6 minus 2x minus 2 times 4 is 8, and then 3 times x plus 4, and then on the bottom I still have my x plus 1. Now I can consolidate these denominators, and 6 minus 2x minus 8 meanwhile is negative 2x minus 2. Consolidate the denominators, then I will factor the numerator, and as you can see now I can cancel x plus 1s, and now you can evaluate the limit all the way to negative 2/9. The last one is right here. I've shown the whole thing already, but it's basically the same idea where you get a common denominator within your numerator, you multiply 5 over 5 here, 5 and 5, multiply x plus 6, x plus 6, you put this together in one fraction, you bring your denominator down below as we see here, you clean up the top and factor, and then you can cancel out these, and then you can substitute in and evaluate your limit.